If you haven't yet watched video DS04, all about the linked list, stop this video and watch that one now, because this is going to go through the functions of a linked list and needs you to understand how a linked list works in order to explain how the functions work. First of all, I'm going to do all my functions with a single method linked list, not a double linked list, so the links are only going from the start to the end. Our first function is simply add, and this is really simple and straightforward. What we do is we start at where our linked list starts and we say, is our next value set to null, i.e. there's no next item? If not, we move on to the next one and we try this one. Is the next item set to null? No? Okay, move on to the next one. Is the next item set to null? Yes, it is. So we're going to add a new linked list item into that position. Simple, straightforward. Our next function that we're going to have is insert. If I want to insert a new element between, say, elements 2 and 3 here, what I have to do first of all is create it temporarily as a variable, and then what I'm going to do is find out what this link to next is on the second variable, and I'm then going to join mine up instead, and then I'm going to tell the computer to wipe out the link that is currently there and replace that link with a new link to my element. That way you now have it go from first element to second element to new element before it then goes to the third element. What about remove? If we want to remove the middle element here, what we have to do is see what the connection is on the next of this element and make that the connection of the next of the previous element. So what I'm doing out is wiping out the connections that already exist between the first element and the second element, and the second element and the third element. Now I can safely delete, dispose of the element that's within the middle section, and the rest of my linked list structure will stay intact. We sometimes use the phrases push and pop when it comes to lists. Now, all push means is that we add an item to the end. That's what we do in a list. What pop means, though, is we grab the item from the end of the list, return that item, and then remove it. So all we do in this particular instance is break our connection between the last item and the previous item in the same way as we do with a remove, but then we actually return this queue item to the program that needs it, so it can do whatever it needs with that element before it obviously disposes of that element itself. So pop is like a remove, but without actually deleting the element from memory and taking that stage on. So far we've seen adding and removing, push, pop, and remove. So push is just an add, pop is removing the last one without deleting, remove can be removing at any position and actually removes from memory. The only other item that we need to worry about in a list array is actually to get a value at an index. And this is the most straightforward of the lot, because all you have to do is count. Say you want the item at index 0, you just go to the variable. If you want the index at value 1, you find the next item, add 1 to your index, and you're there at 1. If you want 2, you just go to the next one, go to the next one, and then get the value from there. So you just need a loop that adds on to a counter, starting always at your first element, which is element 0, and counting on until you get to the element you want, and then you just return the value. All these algorithms are quite straightforward when you've got a single linked list, but it's when you've got a double linked list that the complexity comes in. If we're wanting to add an item to the end of a list, which is what push does, on a double linked list structure, it's not too difficult really. We just have to have obviously a memory address for our new item. We put that one into the next of our previous item. We have to know what the memory address of our previous item is, and we store that in the previous of our new item that we've just created. But what happens if we want to do an insert somewhere else within the list? Here we have our current linked list. So we have the first element on the left, the last element on the right. And as you can see, the next refers to the next item each time, and the previous refers back to the previous box. Now if I want to insert a new item just between elements 2 and 3 here, I have to do several bits of jiggery pokery. The first one I'm going to do is I'm going to have to create my next to the last item on the list. I then have to create my previous to the previous item on the list. I then have to tell the previous item on the list, hey, your blue line that's just there, don't want that anymore because obviously I'm the important one now, so you need to come off and stop connecting to that previous item, and now you need to connect your blue line through to me. Let's do it nice and thick. So I'm now the next item in the list. Similarly, it has to then tell the previous item, so the last item on the list, the final item, stop connecting your previous to that one, and now you need to connect your previous, again we'll do it nice and thick, to me. So now we've had to do several extra little stages because of it being a double linked list over a single linked list, and although it's possible to do, it is more complicated. Similarly, when we want to remove something, that's going to be tricky as well. What we need to do now is tell the previous item, this is what my next item is, so you now need to be linked to that one. And I have to tell my next item, this is what my previous item is, you now need to be linked to that one. Then I need to destroy, now I've cleared my connections, the element in the middle. One of the big benefits of a double linked list though is traversal. You want to find the third element in the list. That's easy, just like it is with a one-way list. We just follow that one to that one, we're there. But want to go back to the second element, instead of having to start right the way back from the start again and traverse on, we just go back one. And now we're where we need to be for the second element. Simple as that. It's one of the reasons why we do double linked lists, as you'll see when we start using it for algorithms such as searching and sorting, which is what all these elements are used for, that having a double linked list actually makes things a lot more efficient and a lot faster.